So we are going to use our wave data that we collected to review how to use the equation to actually make a prediction. First of all, I want to remind you guys of something from our last unit. This equation has an x and a y in it, right? The x and the y in the equation match the x and the y on the graph. And we'll get into that in just a minute. But I want to write that over here just as a reminder because that's super helpful when you're trying to think about having a number and figuring out where it goes in the equation. So I'm going to put that as a reminder over here. The x and the y in the equation match the x and the y on the graph that we made yesterday, or the other day actually. So I'm just going to put that over here, reminder bubble. Okay. Here's the prediction I want to make. We're going to write it down and then we'll talk about how to do it. When we did our wave data, we just did it with our class, right?
Yeah.
But our class is only part of Red 8. If we put everybody in Red 8 together, so you figure an average class is just a shade over 30 people. So we probably have times 4 classes that are going on at a time, right? Probably about 130 people total on Red 8.
Yeah.
So we're going to make a prediction.
Only 2 classes do it though.
How long
I can't see, it's too quiet.
would it take for 130 people, which is about how many people are in Red 8 if we were to put you all together, to do the wave?
I'll help you as well. I will help you accomplish the goal as a Leon.
Okay. First of all, and this is where we get to review some things. We've got our equation. This obviously goes way off of our graph that we made, right? So the equation is going to be the best bet. 130 people. Question or comment? If you're not sure, then it can wait.
It's a question.
Okay, question.
I was asked that for Leon. What?
Where's people on our graph?
On the bottom.
On the bottom. So which axis is that? So remember how we said the x and the y on the graph and the equation match? So if people is on x on the graph, then where should I put this 130 in my equation? That's as much as I can zoom in without chopping it off. Okay. If you need to, move closer. So where am I going to put this in the equation? If people is on the x-axis of the graph, I should put this 130 where?
I can't hear you. On the x, put it in the x.
Put it in the x in the equation because the x and the y on the graph match the x and y on the equation. Right, Kyle? So let's do it. Let's find out how long it would take if all of Red 8 did the wave. So since this is on x in the graph, we're going to put it in the x into the equation. I'm going to make a little note about that since this was for our notebook. We want some reminders of why we put it there. So this would be on the x-axis of the graph. Which is why we're going to fill it into x in the equation.
Whoa.
Matchy, matchy. Now let's see if we can figure it out. So we're going to drop it in. So 0.3 times 130 plus 1. Your attention should be up here, not over there. No, up here. Ignore it. Okay, so we have to figure out what 0.3 times 130 is. Yeah, calculator. That's what most of you guys would be going for.
0.3 of 130?
Mm-hmm. 0.3 times 130.
39. 39.
39.
Okay, you guys all yelled it out over the top of each other. Okay. 300?
40.
What are you trying to do here?
4 and 0, because 39 plus 1.
Yeah, there we go.
But from like here this way, 0 and
Isn't that silly?
Oh, my God.
So when you said 39.4, that's rounded, right?
It's exactly 39. It's exactly 39.
But we still have to add 1, right?
So 40.
No, it wasn't
No,
39.4.
it was 39. It was solid.
39 even?
Yes. Hold on.
Okay.
Where did she get?
We still have to add 1, right? So we get about 40. And because this is an actual problem, what did we just calculate?
The time you took.
The time. And how are we measuring the time? Yes, when we collected our data. Measure the time in seconds. So we should label this so that we know what we just calculated. So if all of Red 8 were to do the wave at once according to your data you collected as a class, it would take a little less than a minute.
That's pretty fast. Wait,
That's
back?
pretty fast for that many people, yeah.
Back, like this way.
You guys were pretty fast when you were doing your wave though, so.
I think it's because we didn't really fully
Let's do one more.
complete the wave as a dissociative.
Let's say, because we have more than just Red 8, we have plenty of people at our disposal here, right? Let's say we want to keep our wave going for a little longer. Let's try one more prediction. How many people
Can you not?
would we need, or would be needed,
Please stop dating your sleeping paper.
for a 2-minute wave? So 2 minutes, that's a while to keep a wave going, right? Probably going to need quite a few people for that.
I'm saying
Okay, so first of all,
like above 300, no, 260, above 260. What?
so you're thinking somewhere over 300? We'll find out in a minute. Okay, time,
This is 1 minute.
minutes, well, time in general. Where is time on our graph? The Y. So where should I put that in my equation?
Why?
The Y, exactly. So
Why we do this? Oh,
it's on the y-axis of the graph, so we're going to put it in the y-axis of the equation. We'll make a note of that so that we don't forget. On the y-axis of the graph, so we're going to put into y in the equation.
no hair. Who did?
Phone.
Now there's one other thing, and this was intentional. I'm going to scoot this up a little bit, so I'm assuming that you've got your first prediction down.
Oh my gosh.
When we collected our original data, were we collecting it in minutes? How are we measuring it again?
Then we convert.
Yeah, so the data that we used to make the equation was in seconds. So that means that the equation is going to need seconds, not minutes. So you have to pay attention to that.
Like point.
Yeah, and make sure that whatever you're feeding your equation matches with what you use to make the equation. Otherwise, your equation won't work right. So since we use seconds to make the equation, that means that everything it calculates is in seconds. So this isn't hard to convert. 2 minutes is how many seconds?
120 seconds.
That was easy. Okay, but we do have to pay attention to that. So we're going to put a little note just to remember. Equation uses seconds, not minutes. So we're going to convert it. 2 minutes, 120 seconds, right?
40 times 3.
And you guys just said that since it's on y on the graph, we should put it in y in the equation. So if I drop that into the y slot, it's going to look like this. 120 equals 0.3x plus 1, right? So So now what I'm missing is over here. But that's okay because this is just a two-step equation and we've done a million two-step equations this year. So what should I do to solve this? Yep, subtract 1.
Subtract 1, you get 1.
Now I've got 119 equals 0.3 times x. Now what?
Divide 0.3 from both sides.
Keone, you're quick today.
And
What
she
did you
get
tell
it,
us?
yeah.
It's
496.66.
Repeated.
I'll say it.
67.
396.
Did you guys just read it off my calculator?
Okay.
I put it in wrong. Wait, maybe I did that.
396.
repeated.
Okay, so do you guys agree with that?
Yes.
Okay, so we've got multiple people getting that?
So 397 rounded.
Yeah, so that's a good point because what did we just calculate?
The total amount of seconds it will take for the some amount of people.
No, we calculated x. What's on x?
The amount of people it would take to
The number of students. And can I have part of a student?
know.
So it would make sense to round to the nearest student. So 397, since we can't have a fraction of a student. And we can use the about symbol to show that we needed to round that off. And we should label it. So the over 300 estimate that some of you guys were throwing out wasn't too far off. It was over 300, actually even closer to 400.